In this lesson, we will learn how to calculate the distance fallen by a free-falling object. So, determining the distance traveled by a freely falling object. In the previous lesson, we learned that in free fall, the acceleration due to gravity, or g, is negative 10 meters per second squared. So if I drop an apple, we're backdropping apples, and the apple is allowed to fall for, let's say, 4 seconds. We saw that we could figure out the final speed by doing g times t. This was in the last lesson. Negative 10 meters per second squared times 4 seconds. v2 is 40 meters per second, and there should be a negative sign there because it's falling down. Because I dropped the apple, v1 will be 0. So we're actually back to an old kind of problem that we used to do, where I know v1, I know v2, and I know time, and I want to find d. When we used to do this problem in the last unit, the first step would be to calculate v average. So the average velocity between 0 and negative 40 is negative 20. And if I want to figure out distance is just v average times time. The distance that this object falls is negative 20 meters per second times 4 seconds, or negative 80 meters. So the apple falling for 4 seconds will cover negative 80 meters, or 80 meters down. So this becomes 80 meters negative down. Okay, here's a practice problem. A pebble is dropped and falls for 5 seconds before hitting the ground. So you can almost imagine, here's our little pebble, and it's going to fall and hit this ground below, and we know it takes 5 seconds to fall down. And I want you to figure out how fast it was traveling just before it hits the ground, so that means before the ground did any stopping of the pebble, and then how high was it dropped from. So hit pause, try these two questions, and then come back and see the answer. So if I want to figure out question A, I'm going to do the first part of our free fall problems. I'm just going to use the fact that I know the acceleration is g, which means negative 10 meters per second squared. And I'm going to calculate v2 by using the relationship that v2 equals g times t, or negative 10 meters per second squared times 5 seconds equals negative 50 meters per second. So this is how fast the pebble is traveling when it gets down here at the very bottom. To figure out the second part, I'm going to look at an average speed, because remember, I always need the average speed to calculate d. We actually have this relationship, which really just becomes d equals v average times time. So I need to figure out v average. Well, just like you calculate a an academic average, I'm going to take the two endpoints, V1 plus V2, add them together and divide by 2, just like we've done before. Because I used the word dropped, we know that V1 is 0, and we just figured out that V2 is negative 50 meters per second. Forgot that. And I'm going to take the average. So V2 is negative 25 meters per second. I can then go back to my original equation up here, and I know that the average is negative 25, and the time is 5 seconds, and negative 25 times 5 is negative 125. So this means that the pebble falls 125 meters, falls down 125 meters before hitting the ground. So here's another example. This time I'm throwing something up into the air. Toss a rock into the air, and it leaves my hand traveling at 3 meters per second. So we have a little rock, and it's going to go up and then come back down. And I've told you that it leaves my hand, so here's my hand, and it leaves my hand with a V1 equal to 3 meters per second. And we want to know how long it takes to reach the peak. So that peak point is up here. That's the very top of its flight. Here is something, a piece of knowledge to take. At the peak, the velocity will always be 0, just for a moment. So that means when I'm answering question A, my V1 is 3. V2 is 0. Because we're talking about how long it takes to go up and reach this point. So I'm essentially asking you, how long does it take to go from 3 meters per second to 0 meters per second, given that the acceleration is negative 10 meters per second squared? So I'm going to use the idea of the equation that we've used before. A equals V2 minus V1 all over t. So that means negative 10 meters per second squared equals 0 minus 3 divided by time. That becomes 10 equals negative 3 all over t. I need to solve for t. To do so, I'm going to multiply both sides by time. I get negative 10t equals 3 because these cancel out. And then t is going to be, oops, this was a negative. T is going to be negative 3 divided by negative 10, or 0.3 seconds. So the time to go up is 0.3 seconds. For question B, I'm asking you, how long does it take until the rock is back in my hand? So that means, how long does it take for the rock to go up and then come back down? Because I'm assuming the rock lands at the same height that it was released from, the path is symmetrical, or the time to go up will equal the time to fall down. So the time up was 0.3, and the time down is 0.3, so that means the total time is 0.3 plus 0.3, or 0.6 seconds. I can just double it. In part C, I'm asked to calculate a distance. The information that I have is that V1 is 3 meters per second, V2 is 0, and we calculated that the time is 0.3 seconds. So I want to figure out distance. So I'm looking for this distance here. For the rock to get to the top. So the only way that we can calculate distance is from V average equals d over t. We know that that equation then becomes d equals V average times time. So I need to figure out what V average is. So V average, I'm just going to average the two endpoints, V1 and V2. V1 is 3, V2 is 0, divide by 2, the average velocity is 1.5 meters per second. So D is going to be 1.5 meters per second times 0.3 seconds. And that, if I do calculate 1.5 times 0.3, I get 0.45 meters. So it goes up about half a meter.